In example 3, we have a stone statue that needs to be moved. It's too heavy to lift, so Mr. and Mrs. Ecker have to push it. And Mrs. Ecker is pushing the statue with a force of 120 newtons at a 60-degree angle from the ground. And Mr. Ecker pushes with a force of 180 newtons at a 40-degree angle from the ground. So what is the combined force that they exert? And in this case, we could draw a little diagram here, I suppose. So here's my statue. It's perfect, I know. And there's the ground, and we're trying to move the statue this way. You can imagine if you just pushed this direction, it would probably tip over. So in general, you're going to kind of push up and forward a little bit. So if we draw these two vectors, let's draw the first one at a 60-degree angle from the ground. So there's your 60-degree angle, and that's 120 newtons. And then the other one is going to be at a 40-degree angle at 180 newtons. So maybe something like that. If we want to find the resultant vector, this is one of those situations where we're going to want to find the x and the y components of each one, and then what we'll do is we'll add those together and we can find the magnitude. So if we try to find the x and y components for 120, that degree measure was 60. So we're going to do 120 times the cosine of 60. And that'll be 60. Then we're going to do the same thing, but do the sine. So that's about 104. Kind of a weird situation, but we're not doing this with reference to the positive x-axis. You could have definitely done that, but I know that both of my forces are going in the same direction, so we want to keep them either both positive or both negative. In this case, I'm just using the positive values. When we find the magnitude, it really won't matter which one you use, because we'll be squaring those anyways. So the next one we can do 180 times the cosine of 40 degrees. That should be about 138. Oops, that should be an 8. And then we'll do the sine there. So that's 115.7. And then all we need to do is add these guys together and then find the magnitude. So if we add these guys together, we've got 198, and we'll make that 116. We'll keep with the rounding here, so let's make that 116. Just round to the nearest Newton, I suppose. And this one would be 220 then. So to find the magnitude of this vector, that's just the square root of 198 squared plus 220 squared. So we'll try that in the calc. And we've got 198 squared, and that's going to be plus 220 squared. And just one more time, again, if these were negative, just use your parentheses and you'll wind up with the same thing. So I think I got about 296 there. And of course we want to relate the unit, so that's newtons. So that's the total applied force if you add each one of these vectors.